Water. It is an essential part of living. It plays an important role in the survivability of living organisms. Unfortunately, fresh water or consumable water are finite and soon will run out. Sadly, us humans waste water for about 1.7 trillion gallons of water per year, according to the data of US Geological Survey. And as it stands today, some countries are deprived of fresh water. It's hard for them to get access to consumable water, making it hard for them to survive. With the scarcity of fresh water comes with a major health problems. According to the Thirst for Water Organization, by 2030, water consumption will rise by 40%. It follows that many countries will be deprived of consumable water as the years go by. With that, wastewater management is a must to lessen the usable water that we use and consume. In the Philippines, only 10% of the wastewater is treated, and 58% of it is contaminated. And only 5% of our Philippine population has a sewer connected to a wastewater facility. The Philippines has a total of 43 wastewater treatment plants, resulting in an efficient water treatment. On the other hand, not all wastewater can be treated. Only domesticated wastewater can be processed through a wastewater facility. Domesticated wastewater are produced by human activities such as wastewater from kitchen, shower, and laundry, which can be processed through a wastewater facility. Because of the limited treatment facilities, the domesticated wastewater goes directly to the septic tank or in the nearby river. With the increasing amount of wastewater per year, it is necessary that every group of community or city in the Philippines has a wastewater treatment facility to lessen the consumption of the usable water. And with that, let's dive in to the process of wastewater treatment.
The sequential batch reactor serves as the foundation for this project's architecture. This uses a batch treatment method to treat wastewater to lower the biochemical oxygen demand or BOD and chemical oxygen demand or COD. Oxygen is bubbled through the wastewater, resulting in a high-quality effluent with low turbidity. With this arrangement, aeration and clarifying are completed in turn within a single reactor basin. It is possible to achieve an aerobic strategy and promote the growth of desired microorganisms by changing the operational strategy. The project's design incorporates a filter that takes out particles suspended in water. Straining, flocculation, sedimentation, and surface capture are a few of the mechanisms used in removal. The fill phase, the initial step, involves filling the basin with influent wastewater. This influent wastewater provides food for the bacteria in the activated sludge, fostering a favorable environment for biochemical reactions. The react phase follows, during which no wastewater enters the basin and the mechanical mixing and aeration units are operating. Since no new volume or organic loadings are present, the rate of organic removal increases during this phase. Normally, this stage takes 2 to 3 hours. After that, the activated sludge will settle under slow conditions, during which no flow enters the basin and no aeration or mixing occurs. In general, the activated sludge settles as a flocculent material. This stage typically lasts 30 minutes. The decant phase is the fourth phase. The clear supernatant effluent is taken out of the procedure using a decanter. The idle phase is the final step, between the decant and fill phases. The operating method and influent flow rate both affect how long it takes. A tiny portion of the activated sludge at the bottom of the SBR basin is pumped out during this phase. And that will be the detailed whole process on how this water treatment project works.
From this zero waste water treatment facility that we proposed can mitigate the continuous polluting of water bodies by the wastewater that people produce in their every household. Also, this water treatment facility can also help to conserve water supply and limit the water interruption to other areas, since the wastewater that processed in the facility can be reused as a water for plants and for cleaning on everything in our households. Also, the organic compost being produced as a residual from the proposed facility after wastewater treatment can also be used as a fertilizer for plants and trees. From that, it makes the whole facility zero waste during the whole process of the water treatment, since all the components from the facility can be used. From this, future outcome can be attained. First, healthy marine biology can preserve, where clean water and variety of organisms will be observed. Second, continuous service of water supply to no water interruption can be provided by water concessionaire to every community. And lastly, if a community has this kind of facility and know the importance of water treatment, it can create a livelihood from the residuals, since it can be a fertilizer, and from that, they may become an exporter or even an importer of this kind of product.
Thank you for listening to our water treatment plan, and may people take this video as a lesson to start conserving and saving water for us to have enough sustainable water supply for the years to come.